Hi, welcome back. Let's finish rational numbers properly in this episode. On the other recent episode, I couldn't finish well. I think time was not on my side. So the explanation, I realized I was rushing through them. So let's tackle once again terminating decimals and recurring decimals in this last episode of rational numbers. So stay tuned. I'm doing this because it's very important and I will need that in the subsequent video. So we were talking about terminating decimals. What does it mean? And then recurring decimals, what does it mean? Now we know what a decimal is and what a fraction is, right? Now let's understand why we call them these names. Now, if you say terminating decimals, any decimal, it means that any number with a decimal point in it. It could be any number of decimal places, 2, 1, 5, 10, 20, whatever decimal places. So any number with a decimal point in it is what a decimal number. Now, let's see the differences. We have terminating decimals and recurring decimals. For terminating, it means that whenever you divide, or the fraction has does not continue, right? The fraction does not continue indefinitely, because it terminates. It means it stops within a particular frame or a particular number of decimal places. That's what we mean, right? So for instance, we have 0.5. Now 0.5, there's nothing, no extra numbers behind, blah blah blah. That's what it means. Now, do we understand them better when we use the recurring decimals? So 0.5 once again can be expressed as a fraction, and which means that it's 5 over 10. How did you get this fraction 5 over 10? We got it simply because we have something like this. So 0.5, which means that to get a fraction, you start from the decimal point, whatever the decimal point is. You move to the last the back of the last digit. The back of the last digit. You move in steps. So here we can see that we move only once, and then 5 is the last digit. How many times did you move? You move 1. So we write it as 5, which is you start from the whole number, right? Yes, the digit actually. So 5, and then how many steps? 1 step. So you write it 0, 1 0, and then you bring the 1. So it basically be 5 over 10, right? So assuming you have 0.3, this will be what? If I move it once, it what? 3, right? This 3 over 1 0, 1 step, then I bring the 1. So that is it. So the same thing is applicable here when we see negative 0.731. So the same thing, how many steps are you moving? From decimal point 1, 2, 3. 3 zeros, 1, 2, 3 zeros. You bring your 1, and then bring the number there as the whole number, right? So that is 731 over 1000. It doesn't dispute the fact that the negative sign is there, so we bring it back. Now the same thing here. You have now at this point you have 1.06, right? From the decimal point, how many steps are you moving? From 1 to the last place. We got how many steps? 2 steps. You bring the 2 zeros, you bring your 1. Now we have to get a whole number, right? So it's assumed that this decimal point leaves the whole sign. If you leave the whole sign, it's 106. That is what? Terminating, right? It terminates. It doesn't continue indefinitely or forever. That's what it means for terminating decimals. Get this once and for all. It terminates, it stops within a particular frame. It doesn't continue indefinitely forever. Now, if with that understood, let's move to recurring decimals. Now, recurring decimals also says that when we express this in terms of long division, right, we realize that the number or the answer that we get, it continues in a particular pattern, or yes, it continues in a particular pattern, and it repeats forever. A particular pattern, and it repeats forever. That is one thing that you have to get. When you do a long division, for instance 0.3, right, is equal to 1 over 3. Now we will do a long division to get this answer. So let's see, this is equal to, so let's express this in a long division form to get this particular 0.3. And then when we do this in the long division, realize that this 0.3 will continue forever. You see that 0.3 dot 0.3, there's a dot on top of the figure 3. So it means that this particular 3 continues forever, indefinitely. And we are doing math, you can't do this forever. So when a particular pattern repeats, we put the dot on top to get the range or to get a particular cut to make the math easy or simple. And everybody is a standardized format or projections, right? So that is not like you are deciding to do it that way, but based on whatever the question demands, that's what you do. Now let's understand it better when I do the long division. Right, so we see that we had 0.3, and then there's a dot on the 3. And then we are saying that this is can be expressed as what? 1 over what? Over 3. How did you get this? Right? How did you get this? Now this is, bear in mind, this is a recurring decimals. So don't get it twisted with the other one. Don't get confused. Right? So let's see once again. We have 0.3. So 0.3, that is it. And then it's equal to 1 over 3. How did you get this? Or get from 1 over 3 to this particular one? It's after we do a long division. I know some people find it difficult doing long division. So let's see it. I didn't want to just leave any stone unturned or assume that you understand. No, sometimes these things can take you by surprise. So we have this 1 over 3. How do you express this in long division? So it's what? Denominator comes outside the sign, the long division sign, right? And then you bring the 1 inside. Now, so it's what? 3 long division 1. Now, how do you do this? So if you have 3 and then 1, 3 cannot go into 1 direct. 3 is bigger than 1. So what do? We borrow a digit, right? We borrow a digit, and then we bring, that is what you bring 0. So when you bring 0, now this one becomes 10. So now 3 can go into what? 9, right? But before we brought this 0, the moment you realize that the 3 cannot go straight into that particular number here, we have to bring 0 points. That's the first thing to do. 0 point. That's why hence this figure that you got here, 0 points. Then whatever calculation you have to do next. So 3, the long division 1, 3 cannot go into 1. So borrow a number, a digit, probably 10 or so. So bring the 0. Now when you bring the 0, now you bring your point. So now let's see that if 3 can go into what? 10. It can go into it by what? 3. So 3 is 9. 3 times 3 is 9. Now the 3 is here, right? So now you can do your subtraction. 9 from 10 is 1. Now you come again. You realize that 1 has come again and 3 cannot go into 1. So you bring your 0 down. You borrow another one. You bring the 0. So now it becomes what? 10. So if it becomes 10, 3 can go into 10 how many times? 3 times. So 3, 9. You go down again, you're 0. So you realize that when you do this, even with a calculator or whatever, you realize that this pattern repeats forever. 0.3333. This is going to continue forever. And we don't have time to do this. So it's as simple as, for simplicity, we then bring the 0.3 and then bring the dot on top. So that the moment you do it 0.3, you don't need to bring the rest of what? The decimals. The same thing applies to this particular one. The same thing. So here also, expressed as 1 over 11, you do the 11 out, you bring the what? The 1. Now, 11 cannot go into 1, you bring the 0. So, 11 cannot go into 10, you bring another 0. Hence 0.09. To do your calculation, you get to this point. And then the same thing is going to repeat forever. So 0.9, 0.09, then 0.0909, and this is going to continue forever. If you like, take a screenshot, pause the video, because time is not on my side. This is what I have to do, and this is going to continue forever. So what do? Simplicity, you write 0.09 and then you bring this on top, right? So whatever the pattern is, you bring the dot on top. That's the same thing here. So 0.0.9